Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Dear students, Assalamu alaikum. I am Muhammad Abdullah Bhatt, lecturer physics, Boys Higher Secondary School, Kupwara. So today we are going to start a unit known as electromagnetic induction. This is class 12th. जैसा कि आपने अपने वेंटर्स में करंट इलेक्ट्रिसिटी, मैग्नेटिक इफेक्ट्स ऑफ करंट और इलेक्ट्रोस्टैटिक्स पढ़ा है, तो इस यूनिट के बारे में आपको मुझे लगता है इतना ज़्यादा नो हाउ नहीं होगा। इसीलिए मैंने इस यूनिट को चूज़ किया है। तो यूनिट शुरू करने से पहले क्या होता है इलेक्ट्रोमैग्नेटिक इंडक्शन, हमें याद दिलाना होगा ओरस्टेड्स ऑब्जर्वेशन। ये आप बखूबी जानते होंगे। when current flows through a conductor, it produces magnetic field. This effect is also known as magnetic effect of the current. So we can say electric field produces magnetic field. That is, a moving charge is a source of magnetic field. Here B represents the magnetic field that you know. तो इस बात को जहन में रखते हुए, is the reverse of the statement also true? That is, reverse of the statement means if magnetic field can produce what? Electric field, right? Electric field produces magnetic field, but can magnetic field produce electric field? तो दो साइंटिस्ट्स ने इसके लिए काम किया। एक है फैराडे और दूसरा जोसेफ हेनरी। दोनों ने साइमल्टेनियसली इस इफेक्ट को प्रूव किया। मैग्नेटिक फील्ड प्रोड्यूसेस इलेक्ट्रिक फील्ड, लेकिन रिजल्ट तो पब्लिश हुआ फैराडे का एंड द क्रेडिट गोज टू द फैराडे। सो फैराडे इज नोन एज father of the machines. So this phenomena is known as how the magnetic field produces electric field. This phenomena is known as EMI, whose full form is electromagnetic induction. Therefore, electromagnetic induction is the phenomena in which an induced current or induced EMF is produced in a coil oblique circuit. CKT means circuit. In a coil or a circuit, when flux linked with it changes. So phenomena in which an induced current or induced EMF is produced in a circuit or a coil when flux linked with it changes. This phenomena is known as electromagnetic induction. But here the point is, what do you mean by the electric flux? So electric flux, this is similar to the magnetic flux, analogous to the magnetic flux. So magnetic flux, it is the total number of lines, total number of magnetic lines of force, passing through the surface, total number of magnetic lines of force passing through the surface held normal to the direction of magnetic field. Total number of magnetic lines of force passing through the surface held normal to the direction of the magnetic field. So electric field is represented by the straight lines with the arrowhead. In the same way, magnetic field lines are represented by the straight lines with the arrowhead. So this represents the magnetic field. When the lines are parallel, this is a uniform magnetic field. So let us consider a surface in it. So this is a surface which is placed, or a plane which is placed in the magnetic field. Magnetic field is represented by the magnetic lines of force, and the symbol for this is B. If we draw normal to the surface, normal to the plane of the surface, so that is known as area vector also, ds, n cap ds. So let this angle is equal to theta. So these lines with arrowhead represent the magnetic field, and this line, this is normal to the surface, this is known as area vector also. So how to measure the flux linked or associated with the surface? This is equal to, flux is equal to product of magnitude of the product of the magnetic field and area of the surface. Magnetic flux is equal to the product of the magnetic field and the area of the surface. Since it is the number of magnetic lines of force, so it is a scalar quantity represented by phi, which is equal to product of the magnetic field B. If it is a scalar quantity, then we can write it as the dot product. So we can write it as B dot A. So F as phi is equal, flux is equal to dot product of the magnetic field and the area of the surface. Simple. If there is a large number of magnetic lines of force represent the strong magnetic field. So if the magnetic field is large, flux is large. If the area of the surface is large, so large number of lines will pass through it. Therefore, flux depends upon the two factors. One is magnetic field and another is area of the surface. Therefore, phi is equal to B dot A, we can write it as BA cos theta. BA cos theta तो यहाँ पे हम ds को ना ऐसे dA भी लिख सकते हैं। चलो हमने यहाँ पे a लिखा, so phi is equal to BA cos theta. So this gives the magnetic flux associated with the surface which is placed in the magnetic field. Now, there are three cases. One is if the surface, this is magnetic field and the surface is placed parallel to the field. Number one. Number second, this is magnetic field and the surface is placed perpendicular to it. Number third, this is magnetic field and the surface is inclined to it. Here, यहाँ पे देख लीजिए, अगर हम इस सरफेस का नॉर्मल डाल देंगे तो ये अपवर्ड्स होगा, सरफेस तो पैरेलल है, लेकिन ये एन कैप जो आपका है एरिया वेक्टर, दिस इज परपेंडिकुलर, तो यहाँ पे थीटा किसके बराबर हो सकता है? 90 डिग्री के बराबर। सेकंड, अगर सरफेस परपेंडिकुलर है तो सरफेस को अगर हम नॉर्मल डाल देंगे, इट इज थोड़ा सा है ये कंफ्यूजिंग, अगर यहाँ पे नॉर्मल डाल देंगे तो यहाँ पे देख लीजिए, यहाँ पे थीटा आपका बन जाता है 0 डिग्री, 0 डिग्री। तो अगर यहाँ पे देख लेंगे नॉर्मल डाल देंगे तो ये थीटा के बराबर होगा, ये बी है और ये थीटा है। सो फाई इज इक्वल टू बी ए कॉस थीटा। This is the magnetic field linked with the surface, which is your case third. Case third. तो एक केस यहाँ पे आप यहाँ पे लेंगे ऐसे, when theta is equal to 90 degree. When theta is equal to 90 degree, then cos of 90 degree is equal to 0. Implies phi is equal to BA cos of 90 degree is equal to BA. This is because cos of 90 degree is equal to, yes, cos of 90 degree is equal to 0. So no flux is associated. No flux is associated with the surface, which is parallel to the field, that means plane of the surface is parallel to the field. Next, second case, if the surface is perpendicular, that means plane of the surface is perpendicular, then area vector makes an angle of 0 degree. So here we will write phi is equal to B A cos of theta. Here surface is perpendicular to B, then theta will be 0 degree. Implies phi is equal to BA, and this is known as maximum flux. Maximum flux. तो हम फिर से डेफिनेशन पे जाते हैं. Total number of magnetic lines of force passing through the surface held. Magnetic lines of force passing through the surface held normal to the direction of the magnetic field. इसका मतलब ये हुआ कि जब हम सरफेस को एट राइट एंगल्स रख लेते हैं तब मैक्सिमम नंबर ऑफ लाइन्स इसमें से पास हो जाती है, एंड दैट इज नोन एज द मैग्नेटिक फ्लक्स. तो आप देख चुके हैं, इफ द सरफेस इज इंक्लाइंड देन इट इज बी ए कॉस थीटा, इफ द सरफेस इज पैरेलल देन देयर इज नो फ्लक्स, व्हेन द सरफेस इज परपेंडिकुलर then there is maximum flux. So next point, this was the case when magnetic field is uniform. Uniform. Uniform field means strength same at every point. Same intensity at every point. Same intensity at every point. Next, there's a case when magnetic field is non-uniform. Non-uniform. Then what we will do? So this is magnetic field, but this is non-uniform magnetic field. Let us consider a surface which is held inside the magnetic field. So for this we have to divide the surface into the small elements, and let one of the elements is dA or ds, as you wish, dA or ds, and this is the normal to the element, that is n cap ds, and this is the theta, angle between the area vector or normal to the surface and the direction of the magnetic field. Therefore, we can write, if the area is small, there will be the small flux passing through it. That is, d phi is equal to b dot ds. So this is the flux linked with the small element of the surface. If we will divide it into the large number of elements and add them, then we will get, by the process of integration, so we will get phi is equal to integral of b dot ds. So this is the expression for the magnetic flux. Expression for the magnetic flux when magnetic field is non-uniform. In case of the uniform, it is direct BA cos theta, and यहाँ पे हम लेंगे B dot ds और B dot dA, जैसा क्या चाहोगे. Next. Now, unit of flux. आप जानते हो phi is equal to BA cos of theta. So we will write here, B is magnetic field, A is area, and cos theta is perpendicular upon hypotenuse. Base upon hypotenuse. So we will, what is the unit of B? Unit of B is Tesla. What is the unit of A? This is meter square. So unit of phi will be Tesla meter square. Tesla meter square. So simple. This is unitless. The unit of B is Tesla. Unit of area is meter square. Therefore, we can write it as Tesla meter square. And this Tesla meter square in SI system is Weber. Therefore, 1 Weber is equal to Tesla meter square. 1 Weber is equal to Tesla meter square. There is another unit which is known as CGS unit of the magnetic flux. CGS unit is Maxwell. So there is a relation between them. 1 Maxwell is equal to 10 raised to power 8 of Weber. Next. So we know phi is equal to BA. What is A? It is the area of the surface. What is B? It is magnetic field And what is phi? It is magnetic flux. So we can write B is equal to, it is phi upon A, or B is equal to, that is total flux divided by area of the surface. So we can write it as, this is flux density. Flux density. So flux density is nothing, but it is simply magnetic field. So magnetic field is also known as flux density. So magnetic field का यूनिट जब आप जानते हो, this is टेस्ला. So यहाँ पे आपका होगा टेस्ला मीटर स्क्वायर अपॉन मीटर स्क्वायर. ये और ये कैंसिल हो जाएगा. So you will get here Tesla. Now we will find the dimensions of the magnetic flux. Dimensions of magnetic flux. Here, dimensions of magnetic flux. Phi is equal to BA cos of theta. So we know B is equal to, आप फिर से वापस आइए magnetic effects में, magnetic effects of the current. B is equal to, B नहीं sorry, आप जानते हो F is equal to ILB. This is the force on a conductor of length L carrying current placed in a magnetic field. तब यहाँ पे आपका B होगा F divided by IL. इसको अगर यहाँ पे हम यूज कर लेंगे, so you will get here phi is equal to, B के बदले में डाल देंगे F divided by IL multiplied by area into cos of theta. So you will get here फोर्स के, मैंने सिंपल बना दिया है. फोर्स के डायमेंशन आप तो जानते हो, M1 L1 T minus 2 upon I is current, so A, L is length, so M, area, that is meter square, cos theta is dimensionless, so we will get here M1 L1 T minus 2. So sorry. So a length L, and this is L square. So you will get here L and L cancels, L square T raised to power minus 2 A raised to power minus 1. These are the dimensions